Let us consider F distribution. You know the F variate is defined as the ratio of chi-square variates divided by their respective degrees of freedom. Let chi1 square be a chi-square variate with n1 degrees of freedom and chi2 square be a chi-square variate with n2 degrees of freedom. We know that the density function of F is 1 by beta of n1 by 2 comma n2 by 2 n1 by n2 the whole power n1 by 2 f power n1 by 2 minus 1 divided by 1 plus n1 f by n2 raised to n1 plus n2 by 2, and the range of f is from 0 to infinity. To derive the raw moments of this distribution, let us derive mu r dash, the rth order raw moment, expectation of f power r, that is integral 0 to infinity f power r into f of f df, that is integral 0 to infinity f power r n1 by n2 the whole power n1 by 2 divided by beta of n1 by 2 comma n2 by 2 f raised to n1 by 2 minus 1 divided by 1 plus n1 f by n2 the whole power n1 plus n2 by 2 df, right? This can be written as n1 by n2 the whole power n1 by 2 divided by beta of n1 by 2 comma n2 by 2 can be taken out as the common term, and you have f power r plus n1 by 2 minus 1 divided by 1 plus n1 f by n2 the whole power n1 plus n2 by 2, right? So to find this integral value, let me take a transformation. Let n1 f by n2 be equal to y, which implies f is equal to n2 by n1 y, which again implies df is equal to n2 by n1 dy. We have changed the differential element. Let us go for limits. F is equal to 0 implies y is equal to 0, right? F0 means y is 0. F is equal to infinity implies y is equal to infinity. So we have changed the differential element and the limits. Let us go for this mu r dash, which is n1 by n2 the whole power n1 by 2 divided by beta of n1 by 2 comma n2 by 2. Integral, the range is the same, 0 to infinity. F is n2 by n1 the whole y the whole power r plus n1 by 2 minus 1, right? For f I have substituted n2 by n1 by, and here divided by 1 plus y the whole power n1 plus n2 by 2, and for df you have n2 by n1 dy, right? So let me simplify the terms now. n1 by n2 the whole power, see you have n1 by 2 here, here it is actually n2 by n1, here you have n1 by n2. So when you reverse it, this becomes minus r minus n1 by 2, this minus becomes plus. Here again you have n2 by n1. If you write it as n1 by n2, the power becomes minus 1 divided by beta of n1 by 2 comma n2 by 2. Integral 0 to infinity, you have y power n1 by 2 plus r minus 1 divided by, I like to utilize the beta integral to find the value of this integral. So I write it as n1 by 2 plus r plus n2 by 2 minus r, right? n1 by 2 plus n2 by 2 is written as n1 by 2 plus r plus n2 by 2 minus r. R is added and reduced, okay, dy. What happens here? n1 by 2 gets cancelled, minus 1 and plus 1 gets cancelled. So you have n1 by n2 the whole power minus r divided by beta of n1 by 2 comma n2 by 2. See, this integral is of the form integral 0 to infinity x power a minus 1 1 plus x the whole power a plus b, which is actually equal to beta of a comma b, right? I am making use of this. So I get beta of n1 by 2 plus r comma n2 by 2 minus r. This is my a and this is my b, right? So we have found the integral value. Now this is my mu r dash. So to get mu 1 dash, put r is equal to 1 in 1. Okay, you should substitute r is equal to 1 in 1. So I have written it as beta of this plus this comma this, a comma b. Okay, so this is my answer. If I put r equal to 1, I get mu 1 dash is equal to n1 by n2 the whole power minus 1 beta of n1 by 2 comma n2 by 2 into beta of n1 by 2 plus 1 comma n2 by 2 minus 1. This can be written as n2 by n1. This can be written as gamma n1 by 2 into gamma n2 by 2 divided by gamma n1 plus n2 by 2. Right? Denominator of denominator goes to the numerator. So here gamma n1 by 2 plus 1, gamma n2 by 2 minus 1 divided by gamma. When you add these two, 1 and 1 gets cancelled. So you have n1 by 2 plus n2 by 2. This term and this term gets cancelled, right? So this can be written as mu 1 dash is equal to n2 by n1 into, see this gamma n2 by 2, n1 by 2 plus 1 can be written as n1 by 2 into gamma n1 by 2. Let me keep it as such n2 by 2 minus 1, and in the denominator you keep this n1 by 2 as such, and this can be written as n2 by 2 minus 1 into gamma n2 by 2 minus 1. So this gets cancelled, this gets cancelled. So you have n2 by n1 into n1 by 2 into 1 by 2 is taken as the LCM, n2 minus 1, right? So you have n2 by n2 minus 1 as the mean of F distribution. Similarly, if you put n equal to 2 here, you will get mu 2 dash, from which you can derive the variance also. Okay, thank you.